Hi, I'm Mitchell and welcome to another video in the RSP Education series. Today we're going to talk about one of the two critical players in industrial power systems, being switchgear. The other player being transformers. Switchgear, though, is essential for safe and reliable power systems. In this video, we'll explore its key functions, components like circuit breakers and relays, and the various types of switchgear used in industrial automation. Stay tuned for our next video, though. That's where we're going to get into transformers and see how these two systems work together as a team to power industrial operations efficiently. Now, if you like this content and want more educational videos, please like and subscribe. Also, this video, as always, is for educational purposes only. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get started. So what is switchgear? Switchgear is a broad term used to describe a combination of devices that control, protect, and isolate electrical equipment. At its core, switchgear is responsible for managing power flow within an electrical system and ensuring that faults don't disrupt operations or cause damage. Without switchgear, electrical systems cannot operate safely in live power systems due to the risk of overcurrents, short circuits, or arc flash events. Some key functions of switchgear is going to be control. So switchgears are going to control the flow of electrical power by turning circuits on or off as needed. Protection as well. Switchgears are going to safeguard systems against short circuits, overloads, and other electrical faults by disconnecting affected areas. Isolation is another task. Switchgear allows for safe maintenance by disconnecting parts of the system. Now let's break down the major components that make up a switchgear assembly. Let's start with circuit breakers. So these are going to automatically interrupt current flow during a fault to protect the system. Disconnect switches. These are used to manually or remotely isolate circuits, making it safe to perform maintenance. Relays. Relays monitor current entering and exiting the system. If imbalances are detected, which indicates internal faults, the relays are going to trigger switchgear breakers to disconnect the transformer. Switchgear relays also manage overcurrent conditions to keep the transformer from overheating or winding damage. Bus bars are another component. These are going to conduct power within the switchgear assembly and distribute it to various circuits. Fuses, as we can understand, are going to melt under excessive current flow and provide overcurrent protection. Current and voltage transformers. These are transformers within the switchgear that are going to measure system parameters and provide data for monitoring and protection systems. Some protection mechanisms within switchgear. Arc flash mitigation. So modern switchgear is often going to include arc flash mitigation systems like fast-acting protective relays and arc-resistant enclosures to reduce the risk of personnel injury and equipment damage. Arcs are going to happen when breakers separate circuits and there's still energy trying to connect the circuits. Selective coordination. This is going to ensure that only the faulted circuit is isolated, minimizing disruption to other operations. This is done through precise relay settings and breaker configurations. Types of switchgear used. There's different types of switchgear and it's categorized based on voltage, installation environment, and the medium used for insulation and arc interruption like we were just discussing. So categorizing them by voltage, there's obviously low voltage switchgear. That's going to handle up to 1 kilovolt, used in small commercial and some residential systems. Medium voltage switchgear is going to range from 1 kilovolt to 36 kilovolt. That's often found in industrial settings. Then you have your high voltage. That's where it's connected to the utility. That's above 36 kilovolts, used in utility and large-scale power distribution. Now, switchgear is also categorized by arc interrupting medium. So this means, an arc interrupting medium is a material or method used to extinguish the electrical arc that forms when a circuit breaker or switchgear opens to interrupt the flow of the current. The arc is a plasma discharge caused by the high energy of the electric current attempting to maintain continuity between the separated contacts. So efficiently quenching this arc is critical for preventing equipment damage, maintaining operational safety, and ensuring reliable operation of the power system. Some arc interrupting mediums are as follows. There's air insulated switchgear, or AIS. It's very cost effective, but it's very space intensive, takes up a lot of room. Gas insulated switchgear is a lot more compact, a lot more efficient. It uses something called SF6 gas for insulation. There's also vacuum circuit breakers, or VCB, and these use vacuum for an arc extinction offering durability and low maintenance. So switchgear's a vital part, as we now understand, of our industrial automation. It makes sure we have safe, efficient, and reliable power distribution. In the next video, we're going to discuss transformers and how they work together with switchgear to form the backbone of power systems. As always, for a full line of switchgear and hundreds of thousands of industrial products, please go to our website. For any other information or other educational videos, go to rspsupply.com, the internet's top source for industrial hardware.